Hope you're doing well. Welcome to day 10 of pre-algebra distance learning. I just continue. Hope everybody's doing really well. We're going to continue on slope today. Make sure you're hitting me up in those office hours. Be next Wednesday at 3:30 again. And as always, I'm available via email. Also, reminder, make sure if you finish something after I have put in grades, please email me so I can go and verify that you've completed it. But yeah, we're about to get after it. Just make sure you're working your hardest, and looking forward when I get to see y'all again. All right, so let's get it. So today we're talking slope from an equation, and you might remember that slope is the relationship of the rise to the run. All right, so how does it change up and down to how it changes side to side? So as we're thinking about up and down and side to side of our points, up and down on our graph would be like the y's, and side to side would be like the x's. So I'm going to label my points x1, y1, x2, y2, and really just what that means is here's my first point, x and y, here's my second point, x and y. And here's the equation that you're going to use. You're going to use y2 minus y1 over x2 minus x1. Now it looks kind of crazy, but really what it means is the change in y over the change in x, which is what slope is. How does the y change up and down to how does the x change side to side? So I like to set it up like this, the change in y over the change in x. So this is what I say in my head. This is like the mathematic notation. So I want you to see how these line up. So here's that y2. See that y2? Here's the y1. Here's the x2. Here's the x1. So another thing you can do is if you label it, it kind of becomes a substitution problem. So y2 minus y1 is going to be 4 minus 9. And I'll show you that. y2 minus y1 is 4 minus 9. And x2 minus x1 is going to be 1 minus 9. So how does it change in the y's up and down over how does it change in the x's side to side? So 4 minus 9 is negative 5. 1 minus 9 is negative 8. So our slope is 5/8. We're going to always simplify. A negative divided by a negative is a positive. But this right here, that's what my mind always stays at. That's what I memorize. Change in y over change in x. And then my memorization takes me to this. I don't start there. I start right there. So let's check this out. I've got first point and I've got second point. That's all that x1, y1, x2, y2 is. I like to write out my equation, the change in y's over the change in x. So how is it changing up and down? That is my 6 and my 7. So 6 minus 7. How is my point? It's on my line changing side to side. That's my 3 and my 7. 3 minus 7. And that's going to give me negative 1 over negative 4. If you're struggling with this integer stuff, I know some of us might be a little rusty. Don't be afraid to lean on the calculator if you need to. We're going to simplify negative 1 over negative 4 to be a positive 1/4. So if you're looking on like a coordinate plane here, here's 7, 7. Here's 3, 6. And if this is my line, you can see a rise of 1, a run of 4. Here it is, a rise of 1, a run of 4. We're just putting it to a formula because to draw that out every time and then count, especially if points were really far away from each other, it'd be quite difficult. So this is a way to streamline that process. So let's check out. We got 2 more points. I like to label them point 1, point 2. And if I'm going to use the equation, the slope formula, y2 minus y1 over x2 minus x1, okay, the change in y over the change in x, I'm going to have a 6 minus 3, and then a 4 minus 6. And that's going to result in a 3 over negative 2. I'm going to simplify that. And it's not needed, but mathematicians usually put the negative in the numerator. It's not going to change my answer. Both these are negative 1.5 when I do the division. But this organization is the way that mathematicians seem to go. I feel good. Or second place, if this is first place, second place looks something like this. You'll almost never see it in the denominator, though. Even though value-wise, it's cool. It's the same value. Okay, we got to step it up a little notch. Now, this looks scarier, but it is not. I'm still going to go change in y over change in x. So the change in my y is going to be negative 13 to 52. And my change in x is going to be 23 to 22. So I've got a negative 65 in my numerator. And I've got a 1 into my denominator, which is just going to simplify it to a slope of negative 65. See, you wouldn't want to count that. Imagine if you had to go plot those 2 points and then count, from 52 down to negative 13. That'd be a ton of work, and it'd probably end up being inaccurate. So not only is going to this equation going to make us more accurate, but it's going to be more efficient, especially when we get to bigger numbers. All right, guys, get after it really hard. There are some problems to do on Go Formative, and I hope you had a good time on the Desmos. Be good.